Hey there, Dr. Callahan here for week 2 Wednesday for Prop and Stats. Go ahead and get started with your warm-up log. Some of you guys did a question about the warm-up log template. You don't have that quite yet, but I will be passing that out upon return this Friday. I'm super excited to meet all of you guys. And you guys will have the 3 boxes for each of the days. So anything that was completed for week 1, Monday to Friday, and then also week 2, Monday to Thursday, you just keep it and you can staple it onto the warm-up log template when I give it to you guys on Friday. And that will be capped for week 1 all the way to week 9 Friday, because that's when it's going to be due and it's worth 300 points. So question number 1, if you find out your grade, well, you will find out your grade in this class today. I generally have you guys do a grade check once a week. Usually it's on a Wednesday for the regular school year, but since we're on a hybrid model, I might have to revert that to like a Wednesday, Thursday, or Tuesday, Wednesday kind of a thing. But you will definitely find out your grade in class once a week. And I usually print it out on a hard copy and I just kind of pass it around so you could check it. I also update my grades on Infinite Campus once a week, and that's just to keep me on my toes, to make sure that all of your grades are updated on a weekly basis, rather than me holding onto your assignments and then you not knowing what your updated grade is for 3 weeks. So yeah, what do you do if you are missing a quiz? You do get a 0 for being absent, so keep that in mind. Question number 2, how do you undo an exponent? How do you undo a square root? And question number 3, with this question, what do you do first in this equation? What do you do second, third, and finally, what is your answer? So pause the video and answer those questions. All right, so let's go ahead and go over this very quickly. How do you undo an exponent? If you have, let's say, for example, x, if you have x squared, for example, how would you go about undoing the square on the x squared? You would go ahead and put a square root over it to get rid of that. Similarly, if you have a square root, let's say a square root like this, how do you get rid of the square root? You will square it. Okay, so let's go ahead and take a look at this. This is the breakdown of your grades. You do not have any points bigger than 10. That's the most that you can get. If you do have a 10 on Infinite Campus, it means that the assignment that you did or the skills that we covered, you understood the problem completely, and there is absolutely no mistakes made on your part. A 9 means that you set it up correctly, but you made a few very, very minor errors, so that's a 9. 8 means that you made limited errors. 7 means that you set up the problem correctly. You understand little of the concept and show some evidence of understanding it. 6 means that you attempted it, you set up the problem, but you really still have no clue what you're doing. A 5 means that you just showed up to my class and you didn't really do anything. And then if you get an M for 0, that means you were absent for class, which means you need to go ahead and make sure that you get it done. All right, let's go ahead and take a look at question number 3. For first thing they're going to do is they want to distribute this because there is a 2. Remember, this is kind of doing PEMDAS. So PEMDAS. So you're going to distribute this and you are going to multiply it out, distribute. Actually, you're not going to do PEMDAS. I'm sorry, I don't know why I said that, so let's cross that out. 2 times 4x is going to give you 8x. 2 times -2 is going to give you a -4, and then 14 stays by itself. Then you're going to go ahead and simplify it. Well, we did that. We multiplied it out. Add the 4 on both sides because you want to isolate the x by itself, and unfortunately, the x right here is not by itself. The x has an 8 attached to it and also a -4, so you want to isolate the -4, want to get rid of that, so opposite of a -4 is a +4, and then lastly, you want to divide it by 8, and this is your answer. If you want to put this into a proper fraction, it will be x is equal to 2 and 1/4. So this could be your answer as well. Having a little bit difficulty here with my keypad, but that's okay. We'll figure it out. Okay, so your homework was to do 2 to 50 evens. That was on Monday, so we went ahead and corrected that. Make sure you guys have that done. You can go ahead and pause it to take a look at the answers. This is what we covered last class. We did do a Quizlet. I went over my notes on 2.2, which is on probability subsets. There is a YouTube video that was 5 minutes that kind of covered that as well. And then I asked you guys to do a quizzes. It was 10 questions going over subsets, and that was your homework. Keep in mind, you don't need to have a textbook for this class. I have a screenshot of the textbook on my Google Doc for you guys, so just go to the Google Doc. If you're not sure what the Google Doc is, I can go ahead and share that with you guys one more time. When I do come back, I will give you guys little stickers with the link itself, but for the time being, you'll be able to see this right now on the video. So this is the link right here. Keep in mind it needs to have a capital C, capital U, capital W, lowercase c. Okay, and this kind of is your website. It's your hub for everything that you need to have. So everything I do is organized based on days and weeks. So week 1 Monday, this is what we covered. If you want to see the video, there's a link to the video here. Week 1 Tuesday, etc. But we are in week 2 Wednesday. So if you take a look at week 2 Tuesday, this was your homework assignment, and it says right here, homework section 2.2 for week 2 Tuesday, page 65 to 66, 2 to 50 even. This is the screenshot of the assignment, and you'll be able to find that. And if you're absent for, let's say, week 2 Tuesday, and you want to know what we talked about, here's a link to the video of the lecture, just like you're watching this one for week 2 Wednesday. All right, so let's go ahead and proceed on. Today we're going to talk about Venn diagrams and subsets. There is a Quizlet for 17 questions at this link right here that you guys can go ahead and do. If you need to watch another video that's made by somebody else, that's not me. Here's another video for that. And I know you're like, well, these links are really long, Callahan. I mean, like, do you expect us to go ahead and do that? These links are long, but what you can do is you can kind of come back to the Google Doc. And if you take a look over here for week 2 Wednesday, take a look over here. The links right here are already typed in. You just need to click on them and it will take you to the link. So that way you do not need to type that entire lengthy link in. All right, let's go back to this. There's a Kahoot, a Quizzes, and then your homework for 2.3, which is today, is going to be 2 to 16 even, so a total of 8 questions. These are the questions that look like on your homework, and it's also on the Google Doc. This is your exit ticket. You're welcome to go ahead and just write it down somewhere in your guided notes. All right, so let's go ahead and get started with 2.3, Venn diagrams, set operations. And here are your objectives. Okay, universal sets and Venn diagrams. The universal set is a general set that contains all elements under discussion. John Venn was the guy that created the Venn diagram to show visual relationships among sets. The universal set is represented by a rectangle. So this is the set of the rectangle. The subsets within the universal are depicted by circles. So these are subsets of the set, or sometimes oval or other shapes, but for Venn diagrams, it's generally circles. When we do subsets, which we talked about last class, it's not very visual. You have like rosters, you can put in numbers. Like one of the subsets that we had was all the coins that was less than $1. So we had like a penny, 5 cents, 10 cents, a quarter, $50. Okay, so that's what we did. And okay. Whereas with a Venn diagram, it is very visual. Example 1, determine the set from a Venn diagram. Use a Venn diagram to determine each of the following sets. U, if you take a look at the set U, which is this rectangle right here, what are all the elements inside the U? I can say that there is a triangle, a square, a money symbol, the letter capital M, and 5. These are all the elements inside U. Let's take a look at A. What's in A? A is now going to be confined to this circle. So inside the circle, I have a square and a triangle. That's what I have. The elements or the set of elements in U that are not in A. So what is in U but is not in A? Those will be the money symbol, the capital letter M, and 5. Okay, now let's take a look at different types of Venn diagrams. A disjointed set means that you have two different subsets inside the element where there's no commonality, like there's no overlap. Equal sets means that my element within A is going to be the same element that's going to be in B, and therefore they have everything that's exactly the same. Proper subset means that all elements of A are inside elements of B. Sets with some common element, this is generally the one that we use with Venn diagram, means that there's some, at least one, that represents an overlap. So there's something in A that's also in B that they share. It will be right here where that overlap is. Example 2, determining sets from a Venn diagram. Use a Venn diagram to determine U. If you take a look at U, U encompasses the entire rectangle. So you're going to include everything that's in A, everything that's in B, everything that they share, and everything that's outside of A and B. So that will be letter A, B, C, capital I, Roman numeral 2, D, Roman numeral 3, E, Roman numeral 4, F, and G. So these are all of the things that is going to be inside U. Next one is, what is in set B? Well, in set B, you can see that I have a capital letter, or excuse me, the Roman numeral 3, E, and I also have Roman numeral 2 and D. C, the set of elements in A but not in B. So what is in A but is not in B? That will be I, A, B, and C, or Roman numeral 1. E, the set of element in both A and B. So what both means is that what do they both share? Or where is the overlap? So in which case it will be Roman numeral 2 and also D. One thing I forgot is D, the set of elements in U, but that are not in B. So it's gonna be everything here in U, but it cannot include Roman numeral 2, Roman numeral 3, D, and E, because these two are in B. So this is what you should have for D. Eventually, we will have to look at a Venn diagram with 3 circles so that all 3 circles share in between right there. So this is good practice. Start off with 2 because eventually you'll get to 3. The complement of a set. The complement of set A is symbolized by A prime, and it's called prime with a little tick mark, is a set of all elements in the universal set that are not in A. This idea can be expressed in set building notations as follows. So for example, 3, find a set complement. So let U be 1, 2, 3, 4, 5, 6, 7, 8, 9, and A will be 1, 3, 4, 7. So find what is not in A, or what is A prime. So what's not an A means that what is outside of the circle. And those numbers will be 2, 5, 6, 8, and 9 because these numbers are not in A. They're not in the circle. Now let's talk about intersection and union set, okay? The intersection of a set A and B, and let's say that's A and that's B, is written as A intersection. This little symbol means intersection, is a set of elements common to both sets and A and B. So this right here, this green part, is going to be the intersection. This definition can be expressed in set builder notations as follows. The union of a set A and B is written by A union B, and so this U stands for union, is a set of elements that are in A or B or in both sets. This definition can be expressed in builder notations. Essentially, it is to include everything. Intersection is what they share in between A and B. So let's practice with this. Find the intersection with the symbol, what they share. Find each of the following intersections. So what do they share? Here's the intersection symbol. What do they both have in common between these two sets? I can say that they share the number 8, because 8 is in both, and the number 10, because 10 is in both. So my answer is going to be 8 and 10. B, what are the intersection of these two sets? What do they share? Well, if you look at it, there's nothing that they share. First set has 1, 3, 5, 7, 9. Second one has 2, 4, 6, 8. You have odd numbers and even numbers. There is no commonality. So your answer is an empty set. C, what do they share? Nothing, empty set. Okay, example 5. Opposite of intersection is union. So you're going to include everything that is in both sets. Okay, so let's take a look at A. With A, you are going to include 6, 7, 8, 9, 10, 11, 12. Essentially, everything. Not what they shared, but you're going to include every single thing from the first set and the second set. For B, you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, you're going to include everything that's in set first set and the second set. For C, second set is an empty set, so you're just going to include everything in the first set, 1, 3, 5, 7, 9. And that is your answer. Example 6, performing the set operation. Given that U equals this, A equals this, B is this. And it says find A union B, but there is a not, okay? So with this one, you are going to start off with the following. A union B. So what is in between A and B? That is going to include everything. Well, it'll be 1, 3, 7, 8, 9, 10. So this is what I have right here. I'm going to start off with this. Start from the inside. So ignore the prime right now. But then you're going to take a look at this and ask yourself, okay, what is in U that is not in A union B? Because the not here, prime, means not. So what is in union? U, but not here. Well, 1 is there, so not included. 3 is there, but 2 is not in here. Neither is 4, 5, or 6. So these numbers, 2, 4, 5, 6, is my answer. A union B with a prime is going to be 2, 4, 5, and 6. For B, it's saying what is not in A, what is not in B with an intersection. So let's start off with what is not in A, okay? Not in A, so you're going to take a look at U and what's not in A. So that would be 2, that will be 4, because there's a 3, that will be 5, 6, Don't include the 7 because there's a 7 in A. 8, do not include the 9, and 10. So this is what's not in A. Then I'm going to take a look at what is not in B. Not in B will be 1, 2, don't include the 3 because there's a 3 here. 4, 5, 6, don't include the 7 because there's a 7 in B. Don't include 8, 9. And that's exactly what you have right here. Okay, now that you have not in A and not in B, the symbol in between them is an intersection, which means what do they both share? So what do they share? They share a 2. They share a 4. They share a 5. They share a 6. And that's it. So your answer for B, what is not in A and what's not in B for the intersection of the two is 2, 4, 5, 6. And that is your answer. That is all that I'm going to cover today for this section of week 2 Wednesday. Make sure you guys have your assignments completed and make sure you guys finish your homework 2 to 16 evens, which is 8 questions. Have a great day, you guys.